I'm Brian Mycroft, the Chief Technologist with AWS, and I'm going to talk to you today about the AWS Nitro System, and very happy to have everybody coming out to learn a little bit more about AWS, so that's great. So I'm going to start by just driving into the history of Nitro. I'm then going to dive a little deeper into how Nitro's built and put together. I'm then going to talk a little bit about performance. I'm going to talk about how Nitro is, the AWS Nitro System is a security differentiator for AWS. And then I'm going to just talk about how that's enabled AWS to unlock and deliver on a number of different innovative technologies and help you. And I'll just summarize some of the things that we talked about. One of our VPs always likes to refer to our data centers as containing alien technology because AWS's data centers look nothing like a commercial data center. A number of customers are surprised, but AWS does design and build its own data center networking, servers, and silicon as well. So it has been a journey to get to this point, and I'm hopefully going to walk through some of that journey and how we've got where we are today. So it all started in 2006 when Amazon released the first EC2 instance. It was just called Amazon EC2, and it was it had the specifications that are I don't know where to point. Sorry, they didn't give me a laser pointer. So, anyways, they has the specifications per the slides, but at the end of the day, it eventually got renamed as the M1 small instance when we released the M1 large instance types inside AWS to offer more compute memory and storage capabilities on the instance types. So then over the next 10 years, we launched an additional 27 instance types, which were supporting millions of customers, tens of millions of different customer instances. But these instances were all based on the Zen hypervisor. They used paravirtualized drivers, and they started with no hardware acceleration technology. But at the end of the day, customer adoption of the Zen EC2 instance types far exceeded AWS's expectations and has led to where we are today as a company. So then we started to ask ourselves, the Zen paravirtualization, delivered on some capabilities, but we really wanted to deliver more for our customers. So we started and we initiated designing a new architecture to increase performance and security of our EC2 instances. And that started with essentially rethinking virtualization from the core or from the ground up. So it's important to recognize that as bandwidths increase, whether it's in CPU or network or storage, those processes started taking more and more of the core x86 CPU. They started adding latency. There was noisy neighbor impacts. That extra overhead just kept growing as networking and storage speeds increased. So we needed to reserve more and more of our core CPUs that we should be delivering on your workloads and your business outcomes to delivering core hypervisor functionality. So we started to think, hey, how can we simplify the hypervisor? How can we increase customer trust? How can we make it so that there is no operator access to our instances? How do we deliver bare metal instances? Because from a bare metal perspective, how do we guarantee the integrity of the hardware? If there's no hypervisor in the mix. So we looked at a number of different capabilities that we really wanted to deliver and figure out how to innovate and drive new functionality into this new system. So in 2017, with the launch of AWS C5 instance types, AWS launched the AWS Nitro System, and it had been in development since 2012. It was purpose-built hardware and software, an AWS custom-built hypervisor based on 5 generations of AWS custom silicon. So it was an agile, iterative process to get to the outcome of the Nitro System. And all new AWS instance types today launch using the AWS Nitro System. So that's a really important point. If you launch an AWS instance type, if it's any of our newer instance types, you're naturally getting the capabilities and the benefits of the AWS Nitro System. Sorry. So from that perspective, I do want to reiterate and stress that the AWS Nitro System is not AWS Nitro Enclaves, okay? So AWS Nitro System is available to all of AWS's modern EC2 instance types. Doesn't require any special tooling. It doesn't require any special drivers or AMIs. There's no application modifications or custom configuration. Just all of our newer instance types benefit from the Nitro system capabilities. And the AWS Nitro System is essentially AWS solution for confidential computing. Nitro Enclaves takes that to the next level. So if you want to extend the benefits that we've delivered through the Nitro System to your own internal operators, so if you as an organization want to prevent your own IT administrators from having access to workloads, that is where you start to go to that next level and look at Nitro Enclaves. But generically speaking, the AWS Nitro System is what delivers on what customers are typically looking for from a confidential computing capability. It's what we use to deliver on, and as a competitive advantage over some of our competitors, given that it's just naturally available in all of our modern instance types. So if we just step back and look at what did the original EC2 instance host architecture look like running the Xen hypervisor. We had the hypervisor, which typically comes with a console, and we've got networking, storage, and management security overhead there. And the hypervisor and management functionality on a lot of typical commercial hypervisors is taking upwards of 30% of your host or your server capacity. Leaving 70% to run your workload, whatever that might be. So we started on this endeavor to in an iterative manner to redesign this. So in 2013, we started by offloading some networking capabilities. We launched a feature called EC2 Enhanced Networking, and we offloaded some of the networking off of the core hypervisor, off of the core x86 processor onto an externalized card. Then in 2014, we launched the C4 instance type, and we did the same with our EBS storage. We offloaded the storage capabilities off onto separate hardware, AWS designed silicon, which was based on our work with Annapurna Labs, which we started working with right after we launched that networking functionality. And we eventually bought that company as the basis for our silicon innovation and our silicon design labs and helping move this journey forward. And with that, in 2016, we launched the Enhanced Networking Adapter, which further brought networking improvements onto the silicon running inside the custom hardware cards running in our instances. And then finally, in 2017, we launched the Nitro System. We moved the management, security, and monitoring capabilities all out of the hypervisor and down into our customized, specialized cards. And we slimmed the hypervisor down to a very, very lightweight hypervisor. The hypervisor, we removed the networking stack, we removed the storage stack, we removed all the management and security code from that hypervisor and moved it all down onto, I keep wanting to press the laser pointer button, sorry. Anyways, we wanted to move it all down onto, we moved it all down onto the Nitro card. So all of AWS's control plane, management plane functionality was moved off of the hypervisor, off of the x86 processor, and into this Nitro, the Nitro system. And if we just compare these two models to each other, if you look at the classic model, the original EC2 instances and traditional on-premises hypervisors, you've got that you're still consuming over 30% overhead on hypervisor and management functionality. And if you move to the AWS Nitro system, we've really slimmed that down. And essentially, you're getting 100% of the host to run your workloads, your business applications, the content that matters. And we moved all the AWS code off onto that Nitro system. So not only is that providing huge performance benefits from a networking storage capability and enabling AWS to deliver on some of the performance that we've been able to deliver in that space, but it's also vastly improved the security of the virtualization stack. And one of the key things to keep in mind here is on a traditional hypervisor, you've got a console, you've got a domain zero, there's typically a shell with root access, or privileged access to hardware, whereas on the Nitro system, we got rid of the console, we got rid of the the DOM zero OS, completely eliminated that code base. All that code was moved down onto the AWS Nitro hardware, and there is no way from an operator access perspective to get in to the hypervisor. All the AWS code is running on completely separate hardware, so we've got hardware separation there from the hardware that's running the AWS code versus your or customer code, and the management plane security APIs that were moved onto the Nitro system were built and designed with purpose. They're very intentional, and they only provide very specific functionality with no feature set to be able to go in and there's no capability there, there's no API there, there's no possibility of logging into that host, there's no possibility of scraping the memory off that host. We just did not design the APIs in to carry out those particular capabilities. So we designed it from the ground up to block and prevent operator access from that particular perspective. So if we dig a little bit deeper into some of this, the Nitro system is really comprised of about 4 different components. We've got the Nitro cards, which I've alluded to a couple of them. There's networking card, there's some storage cards, most significant being the Nitro system controller card. On our x86 motherboard, we've also put a Nitro security chip right on that card, which traps all I/O to non-volatile storage, protecting the integrity of the x86 motherboard in itself. And I've talked a little bit already about that lightweight hypervisor that provides bare metal performance. And then just recently, we also launched a trusted platform module compatible or compliant with the 2.0 specification that provides you with instance health attestation, or brings some of the capabilities that I'm going to talk to in a moment up to the operating system level that's running on these hosts. So what does the Nitro architecture actually look like? When we're talking about the Nitro architecture, we're really replacing the software device models with hardware devices on the system bus. So the only thing that Nitro presents up to that guest OS is essentially an NVMe device. So any NVMe driver can be used to talk to it, and an ENA, an Elastic Network Adapter device is presented up into that guest OS. Other than that, from a guest OS perspective, it just looks like a standard x86 architecture or motherboard. When this, the Nitro controller, the Nitro cards, the functionality delivered by the Nitro system are all delivered through Nitro cards that are plugged into and connected through the PCI bus. And the communication is all through just standard hardened ENA and NVMe protocols that are behind. They're all standard ENA and NVMe, well-defined, hardened APIs, which then we can innovate behind those APIs and such that customers don't have to, as we add features, as we add functionality and enhance the capabilities on the back end, there's no need to update the guest operating system with different capabilities. So you can see the complete segregation or hardware isolation between the hardware that's running AWS code and talking to the AWS control plane, and the Nitro hypervisor, the instances that are running your workloads, and enabling us to use relatively cheap hardware to accelerate a range of different issues, whether it's talking to storage or provide some of those networking capabilities. So when we start talking about the Nitro cards, there was a number of Nitro cards that I talked about. From a networking perspective, it's the Nitro card for VPCs. The Nitro card for VPCs is, again, presents itself up as an ENA Elastic Network Adapter PCI controller. Drivers are available for all major operating systems. And essentially, this offloads all the data plane capabilities out of the hypervisor and onto the Nitro system. It takes care of AWS's software-defined networking, packet encapsulation as we put packets on the network. It delivers on the security group capabilities, AWS's stateful firewall capabilities that are enabled as part of this hardware offering, enforced again on separate hardware than is hosting or running the customer workload or OS. It's part of the capability that allows us to offer unsampled, byte-accurate flow logs. So you've got extreme visibility into your traffic flows running within your environment. And then it also allows us to deliver transparent end-to-end line rate 256-bit encryption. And this encryption is happening behind the scenes without a customer turning it on or even needing to do anything. And we've now got instance types that are delivering up to 800 gigabits per second of bandwidth. So you could have two EC2 instances, with 800 gigabits of bandwidth running between them, transparently encrypted, down at the hardware layer, making sure that nobody has visibility into the traffic that's coming out of that particular Nitro host. We've done the same capabilities for storage. There's a card for EBS, which is our SAN-based block storage, and there's a card for instance storage, which is really storage that's local to our EC2 instances. And again, these are providing line rate encryption, enabling us to do data at rest encryption, offloaded onto the hardware, transparent encryption at the disk level. So all our instance storage on our modern instances that support instance storage are transparently, whether you ask for it or not, also encrypted at the hardware level using ephemeral keys. So a number of different capabilities being built in there. And then the Nitro card, the Nitro controller card itself is what provides that passive API endpoint. The endpoint that, the control plane, you're going to be able to talk to it and say, hey, start instance, stop instance. So very narrowly well-defined set of APIs that are authorized and authenticated to provide, limited set of capabilities to enable you to launch instances and ensure that, AWS doesn't have access to your data from that perspective. This card is what actually coordinates and controls all the other cards. It controls the hypervisor, coordinates the hypervisor, and the Nitro security chip. So one of the things that the Nitro controller card does is when the host boots inside our data center, what ends up happening is the host boots, the Nitro system boots. The Nitro system is essentially its own processor or computer in itself. We then hold the x86 motherboard in wait state. We then interrogate and inspect the x86 motherboard, checking the posture of that motherboard, and assuming that the posture is as we expect, all the code, all the hashes match, all the firmware's in good state. We then allow the x86 motherboard to boot. So we've got strong control and visibility into ensuring that x86 motherboard is exactly in the state that we expect it to be. We're essentially treating the x86 motherboard as a peripheral of the system. We're switching the model and turning the Nitro system into the actual computer, and making sure that untrusted peripheral is in a good posture or good state before we allow it to boot up and process customer workloads. So how do we do that? On the x86 motherboard, we've also got a Nitro security chip. As I stated before, that Nitro security chip traps all I/O to non-volatile storage. And it prevents the guest operating system or anything running on that x86 motherboard from providing any write access to that firmware. So in a traditional host or a traditional system, whatever the operating system that is running on that motherboard, has access to update your BIOSes and your firmware and your baseband controllers or whatever components exist there. The Nitro system is being placed in between your standard operating system and standard guest access, and preventing any write access. So it's not possible for a user or a workload to upgrade the firmware or change the posture of the hardware system. So we're providing a hardware root of trust. When we need to, when the system boots, obviously that Nitro system controller will, again, working through the Nitro security chip, will interrogate and inspect the posture of the different firmwares on the system and make sure they're valid and allow the system to boot. But this is really what's enabled us to release and launch bare metal instances. Because prior to this, AWS had no way of guaranteeing that if we allowed somebody to start a bare metal instance before we had the Nitro security chip, they could potentially affect the state of the motherboard and put it into a untrusted state. So we've allowed, by putting the Nitro security chip in, by adding these extra validations, which do the proper checks to validate that the signed firmware actually matches what it's supposed to, allows us to have strong guarantees that the posture of that motherboard is exactly as we expected. And then finally, just a little bit more on the Nitro hypervisor. When we first started, we were using the Zen hypervisor. I already talked about the domain zero access and us removing that console and switching to a very light, thin hypervisor. I've already stated that AWS is really inverting the model. The Nitro card is being actually turned into the server. All processing to launch and manage instances is physically separate from where the customer code is running. So again, I want to stress that customer code runs in a separate processor, separate memory than AWS code. Even if someone has full access to the Intel CPU, if they figure out how to break out of the hypervisor, there is no access to the Nitro cards. Peripherals can't get to Nitro, end of story. Our hypervisor doesn't even have a networking stack. It doesn't have a storage stack. It can't talk TCP. It can't write to disk. It doesn't have drivers. It's a very minimalistic, lightweight hypervisor that simply deals with memory and CPU allocation. The other thing that is unique from a lot of traditional hypervisors is when AWS assigns a customer's workload to a core and to memory, we dedicate the core and the memory to that particular customer. So there is no, two different customers do not run on the same core, do not share memory, do not share the same cache. We provide that level of isolation such that we have typically not been impacted by some of the the cache vulnerabilities or the side channel vulnerabilities that have been occurring over the last several years. And then finally, just reiterating the Nitro TPM module, bringing some of that attestation capability and visibility into the attestation and the health of the underlying hardware, and bubbling visibility up to the operating system level, providing the ability to detect when a guest operating system or image, customer image, has been tampered with, and allowing the system to only release the encryption key if the hashes of the images match, and only boot the image if it has been unmodified. So, the TPM module is and does conform to the TPM 2.0 specification from that particular perspective. Enables things like BitLocker and LUX type capabilities from that perspective. So I said I was going to then drill down into a little bit more on how Nitro is helping from a performance perspective, what we're doing to security, additional things we're doing to verify instances and hardware, and how it further enables AWS to innovate and deliver new functionality. So we'll start with performance. So as you can see here, when AWS started offering bare metal instances, which essentially, well, it does entirely remove the hypervisor. So even that's thin wedge of a hypervisor we remove in that particular case. You can see the performance impact is less than 1%. So, the Nitro hypervisor has very minimal overhead on the system and provides near physical like performance capabilities to a bare metal instance. So you're not being impacted in any significant way, whether you get a bare metal instance or whether you get a Nitro System powered EC2 virtual machine. Similarly, if we start talking and looking at latency, if you look at the classic EC2 instances that were powered by the Zen hypervisor, you'll see, latency is between, 30 and 85 microseconds. Very diverse range of latency, so a lot of jitter, not a lot of predictability in the latency you potentially achieve. When we went to the AWS Nitro System, we've been able to pull that latency down in the 9 to 17 range. So we've really reduced the latency and we've really tightened up the range. So you have a good level of confidence in the level of latency you're going to typically get. And when we released the Graviton processor, so AWS makes its own ARM processors as well. The ARM processor enabled us to tighten that up even further to get down around 5 microseconds of latency and really pull in so it's more predictable around the 5 milliseconds as well. So tightening up latency, tightening up the jitter, the predictability of that latency you're going to get, compared to the classic instances where the tail latency was going as high as 1,000 microseconds on those classic Zen instances where the cores are maybe being shared with the hypervisor-based code. And then, if you compare to, other industry vendors as well, we're seeing that the Nitro System provides, on average, about a 14% better performance over, a traditional server or is available from other vendors. And not only did the Nitro System, and are we looking at the Nitro System from a performance perspective in improving the overall performance, we also are focused on improving performance at the component level. And this chart is just showing, from a Nitro versus a non-Nitro enable instances that we're able to improve storage latency dramatically over non-Nitro based offerings. And from that perspective, AWS actually now builds its own Nitro-based SSDs. Previously, each of our SSD vendors each had their own flash translation layer. That layer is the layer that essentially maps the logical to physical addresses on your SSD drives. It's what performed garbage collection and managed wear leveling. By taking ownership of the Nitro SSDs, we're able to reduce the jitter or standardize. Customers were expecting and asking for more consistent latency, so we're able to lower that jitter by over four times, and we're able to reduce the I/O latency by 60% by tweaking and tuning that SSD firmware to exactly match the requirements that were expected and needed in our data centers. It also enabled us to improve reliability. Because AWS owns the firmware of the SSDs, now we could live update the SSDs firmware. We could deliver faster updates. We didn't have to wait for microcode to be delivered from third-party vendors. And this is what's really enabled us to ensure that all the data that gets stored on those disks is encrypted at the hardware level as the data is written to those disks. So every time you use a instance storage on a EC2 Nitro instance, we use an ephemeral AES 256 key to encrypt the data on that disk. So the key is generated when the instance is booted. The key lives for the life of the virtual machine, And when that virtual machine is terminated, that key is purged, and we've essentially crypto-shredded all the data that existed on that particular disk. So this happens again whether a customer turns it on or not on any of our modern Nitro-based instances. So again, just bringing component-level performance benefits down and into storage performance as well. And then, if we drill into security a little bit deeper, we've talked about, the fact that, the Nitro system enabled EC2 bare metal instances based on, the protections of the x86 motherboard we put in place. We've talked about the Nitro TPM bringing extra security capabilities up and visibility up to the OS level. We talked a little bit about that local instance storage and data encryption. Our more modern EC2 instances, so if you're using, if you're looking for memory encryption, we've got Graviton 2 and 3 processors, and our latest round of Intel processors are also now supporting memory encryption. So you've got encryption of your data while it's in memory inside the x86 processor. And I've already talked about the fact that data is encrypted in transit automatically at the hardware level between EC2 instances, line rate up to 800 gigabits today. And I can't stress enough the isolated hardware capabilities. All the AWS code, all the AWS stack is running on dedicated hardware from the untrusted customer workloads from that particular perspective. So, I can't stress enough. When we started designing the Nitro system, from day one, security was a design goal and outcome, and we designed the Nitro system to provide strong isolation between AWS and customer workloads. Those Nitro cards are physically separate from the hardware running customer workloads. Again, I just want to re-stress and reiterate the physical separation that's there, the fact that the Nitro cards are dedicated CPUs, memory, and extra capabilities to drive in and provide the level of isolation that's required. The fact that virtual instances are all isolated from one another, using the Nitro hypervisor, not sharing cores, not sharing memory, and not sharing cache, all really key and important security features of the Nitro system. And then layering on top of that, I've already stated this, but all interactions with the Nitro system are through a set of narrow, authorized, and authenticated APIs. So there's a very finely controlled list of APIs available in the Nitro system. Those APIs do not include any mechanisms for AWS or any system or person to log into that underlying EC2 host. So there is no operator access. It wasn't designed in. Whether or not we got a lawful order or not, there is not the possibility for AWS to log into that host and capture data off of there. So no interactive access, no SSH, no general purpose DOM0 console type features, and even the debugging APIs that are available on the Nitro system can't disclose customer data. So, and I guess the final point, and I didn't talk much about it when we were on the architecture slide, but that Nitro system is connected to an isolated, dedicated network that's completely separate from the customer network. So the Nitro system instances, the Nitro system itself is not connected to the same network that your customer-based workloads are connected to. We've talked a little bit about VPC encryption, providing always-on, line-light encryption between instances. That encryption works across VPC peering and different AWS customer instances. Unfortunately, today, it's not supported through services like AWS Transit Gateway and load balancers. Just as we move forward, you'll see that capability does become available. But until we get all of our fleets upgraded to the same level, there are some limitations on when that encryption works. And I didn't stress this before, but that encryption is anonymizes anonymizes the traffic and is privacy preserving. So typically when you do network encryption, there's still metadata visible and available to you as to people that are looking at that traffic. But because this is done at the hardware layer, all that metadata, like at the substrate layer or below the software-defined network, all that data is removed. The metadata doesn't exist, so there is no capability to infer different things that you might based on typical encryption capabilities and typical metadata that would be available in other situations or scenarios. So from a security perspective, obviously patching and staying patched is critical. The AWS Nitro system was designed such that we can patch and update the Nitro system without needing customers to do anything. We can do hot patching and upgrading of the firmware on our hosts, of the Nitro hypervisor. Obviously, at the scale we operate with millions of customers and millions and millions of workloads, needing customers to be involved or to reboot their workloads would obviously be unacceptable and would just not allow us to roll out code and updates at the level needed to lock down an issue or roll out new features and functionality as at the rate our customers are demanding. Some of the later versions of the Nitro system have reduced that failover time to dramatically, and we're seeing sub-second failover time to shift over to those new firmware versions underneath. And then from an innovation perspective, the Nitro system has enabled us to launch instances that support from 1 vCPU up to 448 vCPUs today. It's allowed us to launch instances that support graphics, that support accelerated computing, storage optimized, network optimized instances. We've got instances with up to 24 terabytes of RAM. We've got instances running Intel or AMD or AWS processors, and we also now have instances offering Apple M1 processors as well. So the Nitro system, making the x86 motherboard or the core CPU of the system, making it a peripheral, has allowed us to separate the control plane functionality from that untrusted x86 workload or motherboard capability, and allowed us to deliver Windows, Linux, Unix, and Mac operating systems, and over 500 instance types today. So I think that's important to recognize that if you look at the curve before we introduced Nitro, it was fairly linear or flat from features and functionality. With before Nitro, there were 70 instances in instance types in 2017, and today there's over 500 instance types available. And we've continued on that silicon innovation as we've grown there, taking the learnings from building the Nitro system to build the Graviton or the the ARM processor through 3 generations of ARM or Graviton innovation, including releasing machine learning and training type instances as well. Already talked about this. So I've talked a lot about the Nitro system and all the benefits, and I've said that all our modern instance types, all customers are benefiting from the AWS Nitro system. But AWS was looking backwards at our existing fleet of Zen-based instances. There's a lot of customers that are tied to those instances. They don't necessarily want or have the time to figure out how to migrate those workloads or upgrade drivers and whatnot. And from our perspective, OEMs are prioritizing obviously building and shipping newer chipsets and deprecating older hardware. So it was getting very hard for us to support them. But from AWS's perspective, as those instances reached end of life, as we were having trouble supporting them or replacing them, we didn't want our customers to have to force our customers to change. So earlier this year, to help out the over 1.2 million unique customers that were still on the Zen-based version of EC2, we built a Zen emulation layer into the Nitro hypervisor. So customers, starting in Q1 of this past year, we started moving customers' legacy Zen-based instances with no customer involvement, with no customer interaction. We started moving those instances onto the Nitro system as well. So very seamless migration as customers rebooted their instances. When they came back online or rebooted, they were moved onto a Nitro host. That Nitro host had this emulation layer. When it detected the emulation, when it detected Zen, it flipped the emulation flag on, and it emulates all the the Zen APIs. So it requires zero customer involvement, zero driver changes. It doesn't provide any incompatibilities with customer workloads. It looks exactly like an old instance type, yet gains all the security benefits of the AWS Nitro system. So the removal of the service console, the extra access to resources on hosts, the ability to get access to hardware that hopefully fails less because those hosts are getting upwards of 10 years old. So again, extending the lifetime of your workloads that you were potentially already had deployed inside AWS, such that they could live on, potentially indefinitely on those older, based on the older initial build requirements from then. And this just shows, the same picture, but shows that we've added in or put that lightweight hypervisor with no console, now has that Zen emulation layer in there. Again, allowing you to run your instances, your workloads using the same AMI you were for the last 10 years, 20 years, the same OS drivers, and make zero changes and get the capability to do that. So, we started with, C1s, M1s, and a couple of those different instance types, but over time, we will be migrating, all our older instance types onto the full Nitro system and providing these capabilities. Unfortunately, today, any of the older systems that rely on hardware accelerators are not supported with this feature. So if you're using a G2 or a G3 or a P2 type instance type, we don't yet have those capabilities in this particular emulation layer. So, in summary, if we go back to the beginning and look at a typical server, you've got a number of different devices providing local storage. You've got different devices and drivers providing networking and remote storage and co-processors, all managed by that host processor. What AWS has done is we shifted the position and moved the Nitro system into control, the host processor or the workload processor. We've provided a consistent interface to the networking and storage that gets attached to hosts by leveraging the Nitro system, and we've introduced Nitro SSDs to be able to deliver on a consistent, innovative, and continually be able to drive new functionality without requiring updates to what was running on the that x86 motherboard or core processor. And then over time, we've also now come out with our own processor and accelerators. So as we continue to innovate, to be able to drive the level of innovation some of our customers have been asking for, we've actually taken ownership of the complete end-to-end solution, with the Nitro system being the enabler to allow us to deliver on these features and capabilities and continue to deliver at the rate that we've been doing using our custom chips and silicon. So, at the end of the day, it's important to recognize that security is central and fundamental to everything we do at AWS. It's not something that's done as an afterthought. It's not something that's bolted on after the fact. We start with security as core fundamental requirements. It's important to recognize that all Amazon Nitro-powered EC2 instances deliver on confidential computing capabilities. You don't have to go and use Nitro enclaves. You don't have to go and use SGX or other technologies that require you to modify your workloads and applications. It just comes built into Amazon's AWS Nitro system. There is no operator access. The mechanism doesn't even exist, even if we wanted to have it. And there's no requirement for niche technologies or application modifications, as I already stated. And finally, AWS continues on this unique innovation journey on your behalf to build on that decade of silicon innovation. We continue to physically isolate and want to stress that we physically isolate customer workloads from the AWS control plane code. We're providing transparent, anonymized line rate encryption between modern instances, whether you choose so or not. We're providing that transparent line rate at-rest encryption on NVMe type devices. But we continue to try to drive security lower and lower and enable on a more automatic basis, put security as a foundation in everything we do to deliver on your basic virtual machine requirements running inside AWS. And every AWS service is built on AWS Nitro. So as you build and use other AWS services, they inherit a lot of these benefits as well as you deploy. And that's it. So I wanted to remind everybody that we do have free skills builder or digital training courses available for anybody that wants to learn more. And if you want to get industry recognized certifications, there's a link to go access some of those materials, the exam guides. I want to thank everybody for spending the time to come out and learn a little bit more about the AWS Nitro System.